Unit 2, which is on algebra. And we're going to look at section 2.2, which is on exponents, which we can also call indices or powers. The laws of exponents are very, very important. Make sure you know them all, otherwise all your algebra will be a big mess. I'm just going to focus on a few here. So in this case, what you have to notice is that my base numbers are the same and my exponents are different. If the base numbers are the same, I do not multiply them. I keep that same base number and I add the exponents. So if I have two base numbers with different exponents, but the bases are the same, I keep the same one. But if I have one base number to a power, bracket to another power, that's when I multiply the exponents. So clearly, if that is the law for, for multiply, then the law for divide would be subtract the second one from the first one. Okay, notice, what can you tell me about this one? So here we don't have two A's. We've got different bases but the same exponent. So you can, if you like, write them without the times sign, but you can put them in brackets with an M outside. That means this exponent belongs to each number in my brackets. Another one that's very important, if the exponent is negative, and we have done this as well, we said you find the exponent, but you take the reciprocal. So if we do a similar one, what if I had 1 over a to the negative m? So you find the exponent and you take the reciprocal. But over 1 we generally don't write, so that's just a to the m. Okay, let's have a look at this one. I have two different bases, but a bracket to an exponent. So the exponent belongs to both. But if there had not been a bracket, then it's just the top one, that's to the exponent. The bottom exponent is a 1. So brackets make a huge difference. Let's look at examples with numbers. If I had that, if you remember what we said with our bed mass, means we had to first do the exponent and then afterwards add the negative. So it is minus 9. However, if we had this, then my bed mass would say first do the bracket, and that means negative 3 times negative 3, which is positive 9. Okay, let's do one more. What if I had that? Notice the square is not on the first negative, so it equals negative and then minus 3 times minus 3. Negative times negative is positive, and then you do this negative. So, important rule, you must first do the square before you do this negative in front. Okay, fractional exponents. Look at this rule. Notice that the n is in the hook, it's not in front. In other words, I've got an a to the power of m, and it's the nth root. So the power with it stays the power. The one in the hook goes as a fraction underneath. So it's a to the m over n. So this means if I say, what is square root x? You say, okay, well, there's an invisible 1, and square root means an invisible 2. So this is x to the 1 over 2. Right, when you're working with numbers, you can just use your calculator again. So for instance, 3 to the 1 over 5. Just make sure you use your calculator correctly. I'm going to give it to 4 decimals, 1.2457. Right, let's look at powers of 10. This is just something very simple. If I have 10 to the 3, that means a 1 with 3 zeros. If I multiply a number by 10 to the something, it just becomes the 5 with 1, 2, 3, 4 zeros. What would happen if I divided 5 by 10 to the 2? Well, I would say that 5 really has a decimal point after it. Because I'm dividing by the 2, it's got to jump forward, so the point has to go there. So the answer is 0.05. So multiplying and dividing by powers of 10, you just add a lot of zeros, or you just move your decimal point to the right or to the left.